A mass is suspended from a vertical spring and pulled down until spring extended by 12 cm from its unstretched length. Spring constant, what is magnitude of initial acceleration when it is released. So when the stretched spring is released, it moves under the mass here moves under two forces, a downward force, which is the weight, and the upward force is the force in the spring, which is F that equals minus kx. So to get the initial acceleration from Newton's second law, we should get first the F net, and after that equating it with mass times the acceleration. F net is 12, surely after converting it to meter, because the spring constant here is given by Newton per meter, so 30 times 0.12, okay, minus the weight, and the weight here is mass, which is 0.15 times the acceleration due to gravity. This is equal to mass, which is 0.15 again, times the wanted acceleration. Okay, we can remove this mass from here, divide this by 0.14, use your calculator, you'll find A to be 14. Someone may say why you make the F spring positive and not negative. The negative sign refers to the opposite direction to the stretching or to the compression if we compress the spring. But here, when we calculate F net, we are dealing with the magnitude, and the sign or direction is referring to whether it is upward or downward. So we usually take the upward direction to be the positive one, so I choose the magnitude of F to be positive, and weight is downward, which means in negative direction, so I again assign the magnitude to negative. Okay. Sample of radioactive material with half-life 20 minutes, which is correct. After 30, less than half of material decayed. Surely after 20 there will be half of the material decayed, and the not less than half. After 40, all of radioactive material decayed. 40 means the two half-life. After the first one, half of the material decayed. After the second half-life is uh, half of the remaining half. So it the decayed is 3/4, and the remained is quarter the initial amount. Okay. After 60 minutes, each of the radioactive material remains. We should take care whether the material remains or decayed, because this determines whether the choice is correct or wrong. So after 60 minutes, this means that there is 3 half-lives. After the first half-life, half of the material. After the second, it is half of the remaining half, so it is 1/4 of the initial material remains. After the third one, it is half of the 1 over 4, so it is 1 over 8 of the material remains. Okay, so this is a correct answer, and we can memorize this relation 1 over 2n to know how much fraction of the material remains. So if it is 3 half-lives, so it is 1 over 2 to the power 3, which is 1 over 8. If it is 2, 1 over 4, like the case here, 1 over 4 of the material remains, so not all of it decayed. Okay,